Hey everyone, and welcome back to another brainstorm video. In this video we're going to go through the 2017 MCAT. Now what's cool about this is that I actually sat this paper when I was in high school in 2017. So I thought it would be cool to go through and see what I did wrong and pick up maybe some mistakes or common mistakes that students make. Now if we look at the logistics of it, I actually got a merit overall, which is not amazing, right? So if we break the down question by question, I got a merit in the first question, and then an E in the second and third question. So if I got an E in this first question, I would have got E overall. So let's get into the questions. Let's look at question 1. Part A. The distance, D, which is traveled by an object, is given by this equation. D is equal to ut plus 3t squared. They've given us the values of u and t, so u is equal to 3, t is equal to 5, and we need to calculate the distance traveled. So this is a pretty simple application of substitution. So essentially wherever I see a u in the given equation, I'm going to replace it with 3, and wherever I see a t in the equation, I'm going to replace it with 5. So they've given us d is equal to u, so whenever I see u, I'm going to replace it with a 3, so d is equal to 3 multiplied by t, so I'm going to replace that with 5, added with 3 multiplied by t squared, so t is 5, so 3 times 5 squared. Now I can simplify this down, so d is equal to 3 times 5, which is 15, added with 3 times 25. Now we know 3 times 25 is 75, so we've got 75 plus 15, and that's equal to 90. Now we need to write down the units. So what is the units? It is in centimeters, so our final answer is 90 centimeters. So it looks like I didn't have any problems there. We just simply did the substitution and then simplified down to get 90 centimeters. Alright, let's take a look at part B, which is solving the quadratic 2x squared minus 3x minus 9 is equal to 0. Now, as you can see, we have a coefficient greater than 1 in front of our x squared. So that means that we need to use a special technique. So what we're going to do is we're going to first multiply this 2 here with this negative 9 here. So 2 times negative 9 is equal to negative 18. Then what we're going to do is we're going to find a coupled multiple list. Now, the conditions for this is we want two numbers that both multiply together to give negative 18, and they also have to sum together to give negative 3. So what numbers can that be? Let's list them off. We've got 1 and 18, we've got 2 and 9, we could have 3 and 6, and after that we'd start repeating ourselves, so we'd have 6 and 3 and so on. So how can we make these numbers multiply to negative 18? Right, well, for this first one, we could have 1 times negative 18, but that's not going to add to negative 3. So if we look closely, the numbers that are going to do this is probably going to be 3 and 6. The way we can think about this is that if we have negative 6 and positive 3, well, negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. Okay, so this satisfies what we need. So I'm going to rewrite my quadratic as 2x squared minus 6x plus 3x minus 9 is equal to 0. The next thing I'm going to do is I'm going to factorize it in half. So I'm going to factorize these two terms and these two terms. So in order to do that, we need to pull out the common term. So for this first part here, what is common between these equations? Well, we can see they're both multiples of 2, so I can take 2 out, and they both have an x in them. So I'm going to take an x out. So now 2x times what gives me 2x squared? Well, 2x times x gives me 2x squared. Then we move on to our next term. So 2x times what gives me negative 6x? 2x times negative 3 gives me negative 6x. So I'm going to put a negative 3 here. And then we've reached the end of this part here. So this is my first part. 2x multiplied by x minus 3. Let's take a look at the second part now. So what is the common term? Well, we can see that both 3x and negative 9 are multiples of 3. So I'm going to take 3 out, but know that both of them don't have x, so I can't take x out. Now 3 multiplied by what gives me 3x? 3 multiplied by x gives me 3x. And then we move on to our second term. 3 times what gives me negative 9? Well, 3 times negative 3 gives me negative 9. So we're going to put a minus 3 here. And this is all equal to 0. Cool. So now what we want to do is we want to factorize it again. So a quick and easy way to do this is we look for what's in the brackets. So you can see we've got x minus 3 in both of the brackets. So we can take that out. So we get x minus 3 is our first bracket. And then what we're going to do is whatever's left over, so whatever's not in our brackets, we're going to put that into our second bracket. So we've got a 2x and a 3 here. So I'm going to put 2x plus 3 in our second bracket, and that's equal to 0. Cool. So now we're going to solve for the quadratic. So each bracket is going to be equal to 0. So x minus 3 is equal to 0 by rearranging, so adding 3 to both sides. We're going to get x is equal to 3. So one of our solutions is x is equal to 3. Now let's do the other bracket. 2x plus 3 is equal to 0. So I'm going to take 3 to the right hand side by subtracting 3 from both sides. So I get 2x is equal to negative 3. And then I'm going to divide by 2 on both sides. So I get x is equal to negative 3 over 2. So our solutions for the quadratic are x is equal to 3 and x is equal to negative 1.5. Now, if you're wondering, if you're a bit confused on how I've done some of these steps, I have a video on factorizing and I have a video on, the quadratic factorization is in the factorizing video. So go ahead and check that one out. Cool, so if we take a look at what I did virtually the same thing, right? So I found my coupled list, I then expanded it out, or rewrote it, then I factorized it, and then I solved for them, right? And you can see that this is a merit question, right? So pretty generous merit. All right, let's take a look at part C. If 6x minus y is equal to 21 and negative x plus 6y is equal to 14, what is the value of x minus y? So I guess let's look at what we need to do. So we've got two equations here. We've got this equation here and this equation here. Because we've got two equations, we're going to want to use simultaneous equations, find values of x, find values of y, and then find a new value of x minus y. So they don't want expressions, but they want actual quantitative values. So how do we go about doing that? Well, I'm going to rewrite my equations here. So 6x minus y is equal to 21. And my second equation, negative x plus 6y is equal to 14. Now, we can use substitution or elimination in order to solve our simultaneous equations. In this case, I'm going to use substitution because I think it might be a little bit easier. So what I'm going to do is I'm going to take this first equation, and I can rearrange for x or y. In this case, I'm going to rearrange for y. So in order to do that, I need to bring this y over to that side. How do I do that? Well, I do the opposite operation on both sides. So what's the opposite operation of minus y? It's positive y. So I'm going to add y to both sides. So I get 6x minus y plus y is equal to 21 plus y. If I simplify this down, I get 6x is equal to 21 plus y. Now remember, I wanted to rearrange for y, so I need to get rid of this 21 here. So I'm going to subtract 21 from both sides. So I get y is equal to 6x minus 21. Cool. Now I'm going to put equation 1 into equation 2. So what that means is wherever I see a y in this equation here, I'm going to replace it with this expression here. So what do we've got? We've got negative x plus 6 times y. So our value of y is 6x minus 21, and that's equal to 14. Now I've got some expanding to do. So in order to do that, I need to take the outside number and multiply it by everything inside the brackets. So what do I get? I get negative x plus 6 times 6x, which is 36x, minus 21 times 6. Now, minus 21 times 6 is equal to negative 126. So negative 126, and that's equal to 14. Now we want to solve for x now, right? So we've got our equation in terms of x. So by simplifying down, we get 35x is equal to 14 plus 126. 35x is equal to 126 plus 14. So we get 140. Now, x is equal to 140 divided by 35, and that's equal to 4. So we know our value of x is 4. So we've got a value of x. Now we need to find our value of y. So we can substitute x into either equation, and that's going to give us a value of y. So I'm going to put into equation 1. So 6 times 4 minus y is equal to 21. 24 minus y is equal to 21. So y is equal to 24 minus 21. So y is equal to 3. So we've got a value of x and we've got a value of y. So x minus y is the same as 4 minus 3, which is equal to 1. And that's our final answer. So if we look at what I did here, I got a not achieved for this part. Why is that? Well, it looks like I just didn't really understand what the question was wanting to do. So it's really important that when we see two equations, it's likely that we're going to need to do simultaneous equations, right? Now, this question is actually an equation, right? So if you get all the way up to the solution, we get excellence. If we solve for x or if we solve for y, then we get a merit. Or if you just do some expansion and whatnot, you might get achieved. Alright, let's take a look at solving part D. Solve 9 multiplied by 3 to the power of x minus 4, which is greater than 87 when x is a whole number. So how do we go about doing this? Well, we can see that we're dealing with exponents here, right? So ideally what we want to do is get everything to the power, or to the base of 3, so 3 to the power of something for every term, and that way we can simplify down using our knowledge of exponent rules. So can we simplify 9 to 3 to the power of something? The answer is yes. 9 is the same as 3 to the power of 2. So we get 3 to the power of 2 multiplied by 3 to the power of x minus 4 is greater than 87. Now as 87, can we write 3 to the power of something is equal to 87 nicely? Well, it may be hard right off the bat to think about it. So let's write up a power of 3 table. So when we've got 3 to the power of 1, this is equal to 3. 3 to the power of 2 is equal to 9. 3 to the power of 3 is 27. 3 to the power of 4 is 81. And 3 to the power of 5 is 243. Now, if you didn't know what 3 to the power of 5 was, you multiply 81 by 3. That gives you 243. Cool. So, note that we have a power rule, which says if we have the same bases, so let's call our base b. So if we have b to the power of a multiplied by b to the power of c, this is the same as b to the power of a plus c. So we have the same thing going on here. So we can rewrite this part here as 3 to the power of 2 plus x minus 4, which is greater than 87. This can then be written as 3 to the power of x minus 2, which is greater than 87. Now what we want to do is bring 87 and rewrite it as 3 to the power of something. But as you can see from our table here, 87 is not one of these values. Now remember that the question says that x is a whole number and x is in our exponent, so we ideally want this number here to be a whole number. So what this tells us is that because we've got 87 here, this value here must therefore, it can't be 3 to the power of 4. So if we did 3 to the power of 4 is greater than 87, well, we know 3 to the power of 4 is 81. So is 81 greater than 87? It's not, right? What about 3 to the power of 5? So 3 to the power of 5, is it greater than 87? 243 is greater than 87. So yes, it is. So we know that this value of 87, the exact power, sits in between 3 to the power of 4 and 3 to the power of 5. But it's some decimal, so it does not satisfy the condition of x being a whole number. So how do we actually go about solving the question? Well, for now, let's not simplify down this 87 part here. But let's think about it in a more simplistic fashion, right? We just showed that our left-hand side must always be greater than 3 to the power of 4. So 3 to the power of 4 Actually, let's write it like this. So we had x minus 2 here. So we showed that this value of x minus 2 must always be greater than 4, right? Because if it wasn't, then we wouldn't satisfy this equation here, right? So if it was 3, we'd get 3 to the power of 3, which is 27, and that's not greater than 87, for example. So we know that x minus 2 must always be greater than 4. So now, rearranging this equation here, so bringing positive 2 to both sides, we get x minus 2 plus 2 is greater than 4 plus 2. So our final answer is x must therefore be greater than 6. So let's have a look at what I did. Well, you can see here I made the mistake of not understanding what this 87 meant, right? I think when I was doing it, I was trying to, you can see I actually wrote the table here. 3, 9, 27, 81, 243. So you can see that I was thinking, well, 87 is not one of these numbers, so I just automatically went to the next biggest number. And then I solved this equation here. And although this equation, it is correct, I didn't answer what they actually wanted. So this is why I think I've got another cheat here. Now this question is actually an excellence question. So if you are able to correctly find the value of x, so if you correctly found that x was greater than or equal to 7, you would get excellence for that. Alright, let's take a look at the final part of question 1, part E. So we've got Jane here and she's thinking of a number k. When Jane's number is cubed, the answer is m multiplied by k, and when Jane's number is squared, it is n more than k plus 5, so we need to find an expression for n in terms of m. Now there's a lot of letters here, we've got k, n, and m. It's a bit confusing, so let's break it down. So Jane has a number k, so Jane's number is k. We've got an equation here, so when Jane's number is cubed, so Jane's number is k, remember, so k cubed, the answer is equal to m multiplied by k. So this is our first equation. We call this equation 1. Now let's look at equation 2. When Jane's number is squared, so Jane's number is k, remember? So k squared is equal to n more. So n more means n plus k plus 5. So we've got two equations and we want to find an expression for n in terms of n. So that means we need to get rid of our k's. So how are we going to do that? Well, you can see we've got two equations here, so we're probably going to want to use some form of simultaneous equations. So what I'm going to do here first is I'm going to simplify this equation. So I'm going to divide both sides by k. So I'm going to get k cubed divided by k is equal to m times k divided by k. Now, this is the same as k cubed over k to the power of 1. So using our exponent rules, when something of the same base is divided by another thing of the same base, we can subtract the powers. So we get k squared, or k to the power of 3 minus 1, which is k to the power of 2, is equal to m times k over k, which cancels out the k's, and we live with k squared is equal to m. So we've now found a value for k squared. Now, note that in our second equation, we have a k squared. So I'm going to put equation 1 into equation 2. So wherever I see a k squared, I'm going to put an m. So k squared, so m is equal to n plus k plus 5. Now, can we find a value for k using this equation here? Well, if we take the square root of both sides, we're going to get the root of k squared is equal to the root of m. Now, this can simplify further down to k is equal to plus or minus the root of m. The reason we have a plus or minus here is because if I take the negative of the square root of m and I square that, it doesn't matter that it's negative. The answer is still going to be positive. So that's why we have the plus and the minus sign there. Now substituting this back into the equation we just had, we get m is equal to n plus or minus the root of m plus 5. Now, it looks a bit weird that we have this plus sign here and then another plus or minus. For this equation here, NCEA actually specifies you don't actually need the plus or minus sign. So just to simplify things down, we're just going to remove it for now, even though it's not technically correct. So we've got this equation here. So everything's in terms of m or n, and we want to find an expression for n in terms of m. So essentially we want to rearrange for n. So in order to do this, I'm going to need to move all this junk here over to the left-hand side. So how do I do that? Well, everything's being added, so I'm going to subtract both terms on both sides. So what do I end up with? M minus root m minus 5 is equal to n plus the root of m plus 5 minus the root of m minus 5. Now simplifying this down, I get m minus the root of m minus 5 is equal to n. Now these m's cancel and this 5 cancels, so I'm left with n on its own. So this is my final expression. Now, if you're able to get to this final step here, you get an excellence mark. If you're able to do most of these steps, you get a merit or an R. And if you're able to just do like maybe this step here, you get an achieved. Alright, let's have a look at what I did. So I ended up getting an achieved for this part. So I said I found an equation for k cubed and I found a value for k squared, but for some reason I've used an inequality. I don't know why I've done that. And then I've gone ahead and solved for m and I've gotten this here. So that's interesting. But that's definitely not what the question wanted. So I've got a u because I've written these, or I've written at least one expression correct, I think. Alright, let's move on to question 2, part A. We've got an equation here, h is equal to 9 minus 4x squared. We want to give the equation for x in terms of the height. So essentially we want to rearrange for x. So how are we going to do that? Well, we can see that our x squared term here is negative. So in order to get rid of, or make it positive, I can add it to the other side. So how do we do that? Well, we need to essentially use our golden rule. And the golden rule says that we do the opposite operation on both sides. So because we're subtracting 4x squared here, we want to add 4x squared onto both sides. So we end up getting h plus 4x squared is equal to 9 minus 4x squared plus 4x squared. Now, negative 4x squared plus 4x squared cancels out. And we're left with h plus 4x squared is equal to 9. Now, we remember that we're trying to get x isolated. So we need to get rid of this h here. So the order in which we do it is anti-BEDMAS or our SAMDiv. So we do our subtraction and addition first before our multiplication and division. So we need to get rid of this h. Because h is being added, we subtract h on both sides. So we get 4x squared is equal to 9 minus h. Now we've got 4 multiplied by x squared. So you can see we do our multiplication and division before our exponents. So let's divide by 4, because 4 is being multiplied, so we do the opposite, which is division, and we divide by 4 on both sides. So we get this whole equation divided by 4, and this gives us x squared is equal to 9 minus h over 4. Now, we still need to get our x, right, and we're squaring it, right? So in order to get rid of that squared term, we need to do the opposite, which is taking the square root. So we take the square root of both sides. So the root of x squared is equal to the root of 9 minus h over 4. The root of x squared is equal to x, and x is therefore equal to the root of 9 minus h over 4. Now remember that we need to include a plus and minus sign here, right? Because, for example, let's say I had x squared is equal to 9. If I take the root of both sides, I get x is equal to the root of 9, so x is equal to plus or minus 3. So if x is equal to negative 3, let's say x is equal to negative 3, negative 3 squared still gives me positive 9, and that's why we have to have this plus or minus sign here. So this is my final answer because I've rearranged for x. Now, if you're able to get this here, you get an achieve mark, and the mark schedule actually says you can omit these values here, so you don't have to include that. So let's take a look at what I did. It seems that I didn't have any problems here, so I got all the marks for it, but you can see I didn't actually include that plus or minus sign, which is not technically correct, but it's fine. Right, let's look at part B. We want to simplify the following algebraic fraction. So how do we do this? Well, we can see that we've got a quadratic term here, and also another quadratic term here as well. So we need to simplify both the numerator and the denominator and see if we can cancel any terms out. Let's take a look at our numerator first. So our numerator is x squared minus 5x plus 4. So our coefficient in front of our x squared is 1, so we've got 1 times x squared. So as a result, we just do our normal factorizing techniques. So we want to find two numbers that which multiply to 4 and sum to negative 5. So let's write up. We've got 1 times 4, we've got 2 and 2. So which of these will multiply? Well, they all will multiply before, but which will sum to negative 5? If we take negative 4 and negative 1, these will sum to negative 5. Right? So these are our two numbers. So we essentially just put these in brackets. We get x minus 1 and x minus 4. And this is fully factorized for our numerator. Now we take a look at our denominator. Our denominator is 5x squared minus 20x. So normally quadratics are written in the form ax squared plus bx plus c, where a, b, and c are numbers, right? Well, in this case, we can see that we actually don't have a c term, right? We don't have this c term here or a number here. We've only got a and b. So this is a and this is b. So as a result, we can't use our normal factorizing techniques because, well, we've got, nothing to multiply with, right? We can't form our couples. It could be anything, right? So as a result, we're just going to use our normal factorizing techniques, right? So we're going to take our common terms out and see what we can factorize. So what's common between all these terms? Well, the number part, what's common about the 5 and the 20 is that they're all divisible by 5. So we know that we're going to be able to take a 5 out. When we look at our letter part, what's common about x and x squared? Well, they both have x in it. So we're going to take 5 and we're going to take x out. Then 5x times what gives me 5x squared? 5x times x gives me 5x squared. So that's that part done. We move on to our next term. 5x times what gives me negative 20x. 5x times negative 4 gives me negative 20x. So this is my factorized denominator. So this fraction can be written as, fraction can be written factorized as x minus 1 times x minus 4 divided by 5x times x minus 4. Now, what can we simplify down? We can see that we've got x minus 4 on the top and the bottom. So these cancel out. And what we're left over with is x minus 1 divided by 5x. And this is our final simplified form, because we can't get in any smaller, right? So if you're able to get down to this step here, you would get a merit. If you were able to do some form of factorizing, you would have got an achieved. Okay, so it's a bit messy, right? But essentially you can see here, I end up doing the factorizing and I was left with this fraction up the top here. Alright, part C, an L-shaped model is made from this sketch here. They've given us values of the perimeter, or some of the values anyway, and we need to work out the total perimeter. So remember that the perimeter of a shape is just adding up these outside values here. So in this case, they've left out some important values. So they've left out this total size side here. So we need to work out what these values are. Cool, so how do we do that? Well, we know that this length here, or this part here, is equal to 2. And we know that this part here is equal to 4x minus 2. So we're going to sum those together. We actually don't know what the value of this part here is either. So we're going to need to work that out. Well, how do we know what this part is? This part here is the same as this whole part here minus this part here, right? So this is the same as 12x plus 1 minus 2x plus 3, right? So we're taking this and subtracting this part out, or that height out, right? Cool, so now we've got all the sides, and we can just add them up. So let's go clockwise. So we start at we actually better start with the 2 then. So we get 2 plus 12x plus 1 minus, now because we've got the minus in front of the brackets, we need to expand them out. So we get minus 2x minus 3. That's added with 4x minus 2. That's added with 2x plus 3. That's added with 2 plus 4x minus 2. And that's added with 12x plus 1. So we've got a pretty messy sum here. Let's simplify down. So in order to do that, let's see what I can simplify down. So let's start with our number part first. So 2, 3, 0, negative 2, 1, 3, 1, 2. So our number part equates to 2. Adding our letter part or our x values, 12, 10, 14, 16, 20, 32. So we're left with 2 plus 32x. And this is our total perimeter. Now it's actually interesting to know that if you're able to fully simplify that down, you would get an excellence, right? So it's pretty easy excellence mark. Now for this question, I ended up getting a merit. This is because I wrote 32x plus 8, right? But we knew it was 32x plus 2. So where did I go wrong? Well, you can see here, I redrew the diagram, right? And when I recognize that this height here is this minus 2x plus 3, right? But you see, when I minus 2x plus 3, I didn't put this in brackets, right? So I only subtracted the 2x and then just added 3 on. We know that this should be minus 2x plus 3, so this should actually become 12x plus 1 minus 2x minus 3. So it's really important that when we do substitution, that if we're substituting an expression in, we put it in brackets so that we can see if there's a negative sign, we can expand it out, right? Or make all the signs, or flip all the signs so that the positives become negatives or the negatives become positive. Now, for the second part of C, we're told that the area of the model is 92 centimeters squared, and we want to know the value of x. So how do we work out the area of this model? I've put the shape here again. So essentially, we can split this shape up into two rectangles, right? We have this rectangle 1 here, and we've got this rectangle 2 here. So by doing this, we can say rectangle 1, so that's this long one here. We know that area is the same as base times height, right? For a rectangle, right? Area is equal to base times height. So what is the area of a tall rectangle? It's the same as 12x plus 1 multiplied by 2. Now, let's do the area for the second rectangle as well. Well, the area is going to be 4x minus 2 multiplied by 2x plus 3, right? So this was our width, and this was our height, and then this was our height, and this was our width for the first rectangle. Okay. So now the total area of the shape we know is going to be area is equal to the area of 1 added with the area of 2. Now let's expand these out, and then we can do our sum after that. So 12x multiplied by 2. So by expanding, we need to draw arrows like this. So we're going to multiply 2 by every term inside the brackets. So 2 times 12x is 24x, added with 1 times 2, which is 2. Now, for part 2, we've got 4x, so I'll draw it like this, eh? So hopefully it's a bit messy, but essentially, because we've got 2 bracket expansion, we need to multiply every term in the first bracket by every term in the second bracket. So 4x times 2x gives me 8x squared. 4x times 3 gives me 12x. Negative 2 times 2x gives me negative 4x. And negative 2 times 3 gives me negative 6. So we've got area is equal to 24x plus 2 added with 8x squared plus 12x minus 4x minus 6. So actually, this part here should be in a bracket because we're just adding an expression in, and so should this part. Now let's simplify down. So because we've got a plus sign here, we don't have to do any sign flipping. So we get area is equal to 24x plus 2 plus 8x squared, and I can simplify these two terms down, 8x minus 6. Now we can further simplify our like terms by combining equation 1 and equation 2. So area is equal to 24x plus 8x. That's 32x. So we've simplified these two terms down. Let's simplify our x squareds. So we've only got one of them, so we just put that as plus 8x squared. And then we simplify our number part down. So negative 6 and 2 gives me negative 4. So we know our area in total is equal to this here. Now if I rewrite this with the x squared term up front, so area is equal to 8x squared plus 32x minus 4. Now, note that they've told us the area of our model. It's 92 centimeters squared. So 92 is the value of a. So let's substitute that in now. 92 is equal to 8x squared plus 32x minus 4. Now remember that when we want to solve for x in a quadratic, we need that y value to be 0. So we're going to move this 92 over to the right hand side by subtracting 92 on both sides. What that leaves us with is 0 is equal to 8x squared plus 32x minus 96. Now, because the coefficient in front of our x squared is 8, it's not 1, so we're going to need to use that technique for factorizing where we multiply 8 and negative 6 together. The problem with that, right, is that 8 times 96 is a big number, so it's going to be pretty hard to use that number to generate a list and then work out which ones sum to 32x, right? Instead, what we could do is we could factorize this term here, because each number is a multiple of 8, and then see if we've got a quadratic, which is a lot easier to work with. So because they're all multiples of 8, we can rewrite this as 0 is equal to 8 multiplied by x squared plus 4x minus 12, right? And you can expand this and check that this is equivalent to this quadratic up here. Now, x squared plus 4x minus 12 is a lot easier to work with, right? So let's go ahead and factorize this. So first we generate a list from 12. So we've got 1 and 12, 2 and 6, and let's go 3 and 4 as well. Now we want to find one pair that will multiply to negative 12 and sum to positive 4. So if we take 2 multiplied by negative 6, it should be negative 2 summed with positive 6, that gives me 4. And that also multiplies to negative 12. Right, so these are the two numbers that we want to factorize into. So we get 0 is equal to 8 bracket x minus 2, and then in our second bracket we have x plus 6. Cool, so now we can essentially solve for x. So we've got two brackets, so we're going to have two solutions. In our first solution, we've got 0 is equal to 8 multiplied by x minus 2. We divide 8 on both sides, so we get 0 divided by 8 is equal to x minus 2. 0 divided by 8 is 0, so 0 is equal to x minus 2. X is equal to 2. So that's my first solution. Now remember that we are talking in terms of centimeters, so I should put centimeters down. For my second solution, I've got x plus 6. So, what's that? 0 is equal to x plus 6. Subtracting 6 from both sides, we get negative 6 is equal to x. So x is equal to negative 6 centimeters. Now, it doesn't make sense for us to have a negative answer, does it? Because x can't be negative, so cannot be negative. My final answer can only justify it being positive, so my final answer is x is equal to 2 centimeters. Now this question was quite a lot of work, so if you got x is equal to 2 centimeters, you get a excellence. Alright, so what did I do? Well, you can see I've done pretty much the exact same thing. So I showed that we've got two rectangles of the same size. I then essentially wrote the areas added together and that it was equal to 92. Then I simplified it down and then I factorized it using that factorization, special factorization technique. I said that rectangles can't be negative, and so I found x is equal to 2, even though I didn't put centimeters there. So that was cool. Alright, let's look at the last part of question 2, part D. We've got the bro Leo. He's laying some square concrete tiles. He starts laying them down to form a square pattern, but his mate says he should lay them down in a rectangle. He changes his layout to make the length of the deck 6 tiles longer and the width 4 tiles shorter. He finds he needs 2 extra tiles in order to complete the rectangular pattern. So how many tiles did he have to start with? Now this sounds like a bit of a tricky question, so let's go through step by step. So he starts by laying them down to form a square pattern. So we're going to start with a square. Now, his friend thinks it would be better if they laid it out to form a rectangle. So we're going to have square, and it becomes a rectangle. So we go from a square to a rectangle. Now, because we're talking about tiles, the area, okay, of the square and the area of the rectangle is the same as the amount of tiles, right? Because whatever's inside the square, it's got to be the amount of tiles that Leo had. So he changes his layout to make the length of the deck 6 tiles short. Okay, so because we've got a square here, one of the properties of a square is that the sides are equal length, right? So we could call this the height of the square, let's call it x, and let's call the width of the square x, right? Because they're the same value, right? So if we want to quantify this in terms of the rectangle, he makes the length of the deck 6 tiles longer. So our length is this here, right? So he makes the length 6 tiles longer. So whatever x was, he added 6 to it. So the rectangle is 6 plus x, or x plus 6 on the length, and the width of the deck 4 tiles shorter. So whatever x was here, it's minus 4 now because he made it 4 tiles shorter. So he finds he needs 2 extra tiles to complete the rectangle pattern. Interesting. So what they're saying is that this area required 2 extra tiles for area. So we want to know how many tiles did he start with. So because we're talking about the tiles is to do with the area. So let's work out the area of the square first. It's the same as width times height. So x times x, which gives me x squared. Let's do the area of the rectangle now. This is x plus 6 on the length and x minus 4 on the width. So we're going to need to expand this out. So we're doing a double bracket expansion. So I multiply x times x, x squared. X times negative 4 gives me negative 4x. 6 times x gives me positive 6x. And 6 times negative 4 gives me negative 24. If I simplify this down further, I get x squared plus 2x minus 24. Cool, so I've got the area of the rectangle and the area of the square. So what other knowledge do we know, right? We've kind of hit a brick wall. So can we set our equations equal to each other? Do they have the same area? The answer is no, they don't have the same area. So what can we say about the areas? We know that the area of the square is equal to the area of the rectangle minus 2. Now the reason for that is that we said we need 2 extra tiles to complete the rectangular pattern. So whatever the area of the rectangle was, if we take 2 of those tiles away, so those 2 extra tiles away, we're back at the area of the square. So the area of the square is the area of the rectangle minus 2. Now because we have expressions for area of the square and area of the rectangle, let's substitute that in. So area of the square was x squared. That's equal to x squared plus 2x minus 24 minus 2. Let's simplify down now. So because we've got essentially a quadratic here, let's see what we can simplify down. So let's move everything to the left hand side. We're going to get x squared minus 2x plus 24 plus 2. This gives me x squareds cancel out, so we get, sorry, this is all you can 0. Negative 2x plus 26 is equal to 0. Now let's move our 2x back. So we're going to add 2x to both sides. We get 26 is equal to 2x. Dividing by 2 on both sides to isolate x, we get x is equal to 13. So have we answered the question? Have we worked out how many tiles we had to start with? The answer is no, right? Our value of x is one side of the square. So in order to work out the total number of tiles, which we already discussed was the area, we need to use our area equation. The area of the square is equal to x squared, so x is 13. What is 13 squared? It's 169. So we had 169 tiles to start with. Now, no surprises there. If you're able to solve for 169, you get an excellence. A little bit less work, you'd get a merit, so that involves setting up our expression with 6x plus 6 and x minus 4 and setting it equal to, so working out this potential was a merit, and if you were able just to do some of this working here, you got an achieved. So let's see what I did wrong. So I ended up getting a merit, right? So it looks like I set up my equation incorrectly. So I should have had the area of this is the area of the rectangle, minus 2 is equal to x squared, but I added 2. So if I wanted to add to it, I have to put it on that side. So this is where I went wrong, and I ended up getting x is equal to 11. So I didn't even solve for the amount of tiles, right? However, it looks like I set up an equation correctly and followed it through to the end. So that's why I got the merit. Alright, let's move on to question 3. So, part A, the area of a rectangle can be represented by 3x squared plus 2x minus 40. We need to state the length and the width of the rectangle in terms of x. So how are we going to do that? Essentially what we want to do is we want to take this area. So if we draw out a rectangle here, remember that the area of a rectangle is the same as the base. So our base, or our length, multiplied by the height. So the area is length times height. And when we multiply these things together, we get a squared term, right? So if this area was in centimeters, we'd have centimeters squared. So this is similar to if our height was in terms of x and our length was in terms of x, we would have an x squared, right? So essentially, the area is this here. So if we factorize it, we're going to be able to get the length and the width of our rectangle. So 3x squared plus 2x minus 40. So how do we factorize this? Well, we're going to have to use a special factorizing technique because our coefficient is greater than 1. So first we multiply 3 and negative 40 together. So we get 3 multiplied by negative 40, and that's equal to negative 120. We then need to find two numbers which multiply to negative 120, but sum to positive 2. So we could have numbers like 120 and 1, we could have 60 and 2, 40 and 3. But you can see that these numbers are nowhere close to summing to 2, no matter how I put it. So because we need to get towards 2, the two numbers that we have as a clue are going to be very close to each other in size. So if we try 12 and 10, well, let's do 12 and negative 10. If we multiply 12 and negative 10, we get negative 120. And 12 minus 10 is 2. So these are the two numbers we want. So let's rewrite our quadratic. So 3x squared plus 12x minus 10x minus 40. Then we factorize this in half. So let's factorize these two terms. The common term is 3x. So I get 3x. Now 3x times what gives me 3x squared? 3x times x gives me 3x squared, and 3x times 4 gives me 12x. So that's my first bracket done. For the second half, what's the common term? Well, it looks like the common term is negative 10. So I'm going to take negative 10 out. Negative 10 times x gives me negative 10x. And negative 10 plus 4 gives me negative 40. So that's my second bracket. So now what we want to do is factorize this another time. So we get the common term here is the x plus 4. So we're going to take x plus 4 as our first bracket. And whatever's not in the bracket is our second bracket. So that's 3x minus 10. So the length and the width are these two brackets here, is equal to x plus 4 and 3x minus 10. Okay, let's take a look at part 2 since it's directly related to part 1. So we're going to take the quadratic that we have and we're going to find possible values of x, and we need to make sure we justify our answers. So area was equal to x plus 4 and 3x minus 10 from the previous question. Now when we solve for x, we set our y value to 0, or our a value in this case. 0 is equal to x plus 4 and 3x minus 10. So we have two solutions. We've got x plus 4 is equal to 0 and 3x minus 10 is equal to 0. So solving for x on the first part, We bring the 4 over to the right hand side, so we subtract 4 from both sides. We end up getting x is equal to negative 4. Then we've got 3x minus 10 is equal to 0, so we take the 10 over to the right hand side, so get 3x is equal to 10, and then x is equal to 10 over 3. Now, do our values make sense? The answer is no. So, well, kind of. So we know that for x is equal to negative 4, this cannot be true. The reason for that is that length and width can never be a negative value. So we know that this is definitely not a correct value. Is x equals 10 over 3 a correct value? The answer is yes, that does make sense, right? Because it's positive. So what's the matter? Well, note that the area of our rectangle is bounded by this equation here. So our area was initially 3x squared plus 2x minus 40. And we've solved for what we call the root of the equation. So does that mean only 10 over 3 will work for this equation? If we put any value of 10 over 3 or greater into the equation, it's still going to give out a positive value. So we know our area always must be positive, or yes. So if we let's try a value which is bigger than 10 over 3. For example, let's try maybe the number, let's go for the number 10. So 3 times 10 squared plus 2 times 10 minus 40. This is equal to 3 times 10, which is 100, plus 20 minus 40. That's equal to 300 plus 20 minus 40. So 300 minus 20, which is equal to 280. And that's the units squared. This is still a valid answer, right? So essentially what we're saying is our value of x must always be greater than or equal to 10 over 3. So x must be greater than or equal to 10 over 3. And these are the possible values of x. Alright, so for my solutions, you can see I did the first part correct. So I have stated that the length and the width is 3x minus 10x plus 4. But for the second part, I've done it wrong. I didn't even get an achieve mark because actually I solved for x incorrectly. I said x was equal to 3 over 10 when it's actually equal to 10 over 3. I stated that x cannot be negative, which is good. I stated that the value of x will always be divisible by 10. Now that is definitely not right. So you can see that my understanding was kind of flawed because I tried to write this inequality here, saying that x must be less than 3 over 10, which can never be the case, as we proved before. Alright, let's do part B. We've got 2 to the power of 3x plus 4 is greater than 2 to the power of x squared. We need to find values of x. So remember our exponent rule that if our bases are the same, then our powers should be the same too. Now, we're not dealing necessarily with an equation, but an inequality. So the same theory would hold. If our bases are the same, then the inequality for the exponents is going to hold as well. So we're going to have 3x plus 4 is greater than x squared. And the reason we can do that is because 2 is the same base on both sides. So our bases are the same, so our exponents are the same. Now we've got a quadratic here, but we're dealing with an inequality. So how do we go about doing this? Well, we're going to just ignore the inequality for now, and let's just solve for the quadratic. So we're going to have 3x plus 4 is equal to x squared. Now we want to solve our quadratic. So we need to get everything over to one side. So I'm going to rewrite this as 0 is equal to x squared minus 3x minus 4. So how do we solve for this? Well, we need to factorize it. So let's find two numbers which multiply to negative 4 and sum to negative 3. Let's try 4 and 1. So if I have negative 4 and positive 1, I get negative 4 plus 1 is negative 3. And negative 4 times 1 is negative 4. So this holds. So we can write x minus 4 and x plus 1 is equal to 0. Now let's solve for x. So we're going to have two solutions. We've got x minus 4 is equal to 0 and x plus 1 is equal to 0. Solving now, we get x is equal to 4 and x is equal to negative 1. So this is the solution for the quadratic x squared minus 3x minus 4 is equal to 0. But we don't have that. That wasn't our original question. Our question was an inequality. So how do we solve for x using the inequalities? So we've got two values of x. We're going to plug it into our original inequality and see if the values hold. And depending on what happens, we're going to have some bounds for x, essentially. So let's plug in x equals 4 first. So 3 multiplied by 4 plus 4 is greater than 4 squared. Now let's simplify. 12 plus 4 is greater than 4 squared. 16 is greater than 16. This does not hold, right? 16 is equal to 16. Let's try another one. Let's try x is equal to negative 1. So we've got 3 times negative 1 plus 4 is greater than negative 1 squared. We end up getting negative 3 plus 4 is greater than 1. 1 is greater than 1. That does not hold. So as a result, x is equal to 4 and x is equal to negative 1 cannot be in our solutions. So what is in our solutions then? So what we need to do next is go one to the left and one to the right of x. So if we look at our number line, we've got negative 1 here and 4 down here. So let's go one to the left of the smaller number. So we're going to go to negative 2 and one to the right of the bigger number, which is 5. We need to substitute these in as well. So what's 3 to the power of negative 2? Sorry, 3 times negative 2 plus 4 is greater than negative 2 squared. Solving this, we get negative 6 plus 4 is greater than 4. So is negative 2 greater than 4? The answer is no, right? So anything including negative 1 or less is not going to hold for our inequality. Now, what about x is equal to negative 1? X is equal to 5, So we want to go 1 to the right of 4. So 3 multiplied by 5 plus 4 is greater than 5 squared. We end up getting 19 is greater than 25. Does this hold? Nope. Right, so anything including 4 to the right does not hold for our inequality. So the region that we're interested in is this middle part here. Or, in other words, how can we write this? Well, this is the same as x is greater than negative 1, but less than 4. And this is our final solution. So what did I do? I ended up getting an excellence for this part. Now, what I've done is a bit cheeky. So I've essentially done the factorizing and the solving. I got x is equal to negative 1 or x is equal to 4, and I've put the correct solution down, even though I didn't work out my upper and lower bounds. So it's entirely possible that I fluked this part. In fact, it is possible. That's exactly what happened. I could have written it as this here, so x is greater than or equal to negative 1, or x is less than or equal to 4, and I still wouldn't know if that's correct because I didn't work out my bounds. But in this case, I got lucky and got that excellence mark. Okay, part C. Tane and Pete are raising funds for a sports trip. They need to raise $1,000. They only have 5 weeks to do it. Tane gets paid $15. Pete gets paid $16. Now between them, they work 13 hours each week. What is the average number of hours that each of them work per week if they are to have exactly the amount of money they need? Okay, so how do we do this? Well, we need to essentially, if you read this, we've got quite a lot of information. It seems pretty obvious that we're going to have to use simultaneous equations. So we've got Tane and we've got Pete. So Tane gets paid $15 an hour. So that's $15 times the hours worked by Pete. So actually the first step we should do is clarify what P and T are going to be. So P is equal to hours worked by Pete, and T is the hours worked by Tane. So this is actually incorrect. Tane gets $15 per hour, so it should be 15 times T added with 16 times P, and the total of that needs to equal $1,000. That's equation 1. What's equation 2? Between them, they work for a total of 13 hours each week. Now, we know that they're going to work for 5 weeks. So essentially, the hours worked, so T plus P needs to equal 13 multiplied by 5. T plus P is equal. What is 13 times 5? It looks like it is 65. So T and P is equal to 65. So using these two equations, we can use either elimination or substitution. I'm going to use substitution in this case. So I'm going to rearrange equation 2 because it looks easier. So T is equal to, bringing P to the right hand side, 65 minus P. Now I'm going to substitute 2 into 1. So we get, whenever I see a T, I'm going to replace it with this expression. So 15 times T, so 15 times 65 minus P, added with 16P is equal to $1,000. Then what we need to do is expand. So looks like we have got to use some more algorithms. So 65 times 15, that's 25, 6 times 5 is 30, that's 32. Then we've got 5 and 6. So what's that? 5, 7, 9, 975. I hope I did that right. Minus 15P plus 16P is equal to $1,000. Simplifying down further, what do we get? 975 plus P is equal to 1,000. P is equal to 1,000 minus 975. What is 1,000 minus 975? I believe it is 25, but let's do a check. 25. So Pete works 25 hours. Now we need to work out the hours that both of them work. So we've got the hours worked by Pete. So if we substitute that into either equation, we can work out the hours worked by Tane. So let's put it into equation 2, since that's a simpler one. So Tane plus 25 is equal to 65, because remember, Pete is equal to 65. Hence, Tane is equal to 65 minus 25. Tane is equal to 40 hours. Cool, so if you're able to solve for P and T, you would get an excellence. If you're able to find the number maybe of 1, so maybe of Pete or Tane, you would get a merit. Or if you're able to establish the equations, you would get an achieved. For this part, I end up getting an achieved. Now, I'm looking at this working, and I've set up equations completely the wrong way. I've also solved for Tane and Pete getting 6 and 7 hours, which is definitely wrong. So I think the achieve mark there is a bit of a pity mark. But yeah. Okay, let's look at the final question. A and B are 2 consecutive odd numbers where B is greater than A. If C is equal to B over A minus A over B, we want to give the value of C in terms of A and explain why this is an even number over an odd number. Now, I actually remember doing this question quite vividly when I was sitting in MCAT in the last 5 minutes, and I remember being like, this question is crazy, right? Actually, as a side note, if you go on to study computer science further down the line, maybe at university or something, this kind of topic, or this kind of content is called discrete mathematics. Well, the start of it anyway. So if you do any computer science, you'll inevitably look at proofs of this, right? So I think it's quite an interesting question, actually, but it's definitely quite difficult, especially if it's quite foreign to you. So let's break it down bit by bit. So the first part essentially is we want to rearrange the value, well, we want to get the value of C in terms of A. So what that means is we need to define A and B. So we've got the value A. So what's the value of B? So A and B are 2 consecutive odd numbers, and the B is the bigger consecutive odd number. So if A was 1, then B would have to be 3. If A was 7, B would have to be 9. If A was 11, B would have to be 13. Right? So what's the relationship here? Whatever A is, B is 2 greater. So B is equal to A plus 2. Now, let's substitute that into this equation here. C is equal to B, so wherever I see a B, I'm going to replace it with A plus 2 divided by A minus A over B, which was A plus 2. Now we've got two fractions, we're going to subtract them from each other. So in order to do that, we need to multiply each fraction, or the opposite fractions, by the opposite denominator. So what do I get? I get A plus 2 multiplied by A plus 2. That's divided by A multiplied by A plus 2. Minus. Now the denominators are going to be the same. So I get A multiplied by A plus 2 on the bottom. The top's going to be A multiplied by A. Simplifying this down further, we get, essentially we have A plus 2 squared over A squared plus 2A minus A times A, which is A squared, over A squared plus 2A. Now, when the denominators are the same, we can directly add our numerators. So we end up getting A plus 2 squared minus A squared over A squared plus 2A. Now, can we factorize this down or simplify it down even further? The answer is yes. So, how are we going to do that? Well, if we expand the brackets, you can use two bracket expansion, but there is a trick, which is that if you have A plus B squared, this is the same as A squared plus 2AB plus B squared. So I'm just speeding up the expansion. So A squared is equal to 2 times A times B, so that's going to be 2 times A times 2 plus 4 minus A squared divided by A squared plus 2A. Now, simplifying further, we get A squared plus 2 times A times 2 is going to be plus 4A plus 4 minus A squared, so our A squareds cancel. We're left with 4A plus 4 on the top. On the bottom, what do we get? Well, we get A squared plus A remains the same. So we're left with this interesting looking fraction here. So, did I do something wrong here? I think I did. Alright guys, so I made a slight mistake in the denominator. I didn't carry the 2 over, so it should be A squared plus 2A on the bottom. So we've done the first part where we've given C in terms of A. So this is equal to C. But now we need to explain why it's even over odd. So we need to know the definition of an even and an odd number. So an even number is equal to 2n, and an odd number is equal to 2n plus 1, and n is an integer, right? So essentially we don't even need to know the proofs for it, or I assume you probably don't even need to know what integer is. You just need to know that this is the definition of an even number and this is the definition of an odd number. Now, we know that A is an odd number, so whenever I see an A, I'm going to replace it with 2n plus 1. So C was equal to 4A, so 4 multiplied by 2n plus 1 plus 4 divided by A squared. So A squared is 2n plus 1 squared plus 2 times A, which was 2n plus 1. This is a nice little equation here. We should simplify it down. If we simplify it, this yields 8n plus 4 divided by, what's that? 4n squared plus 4n plus 1 plus 4n plus 2. Now, I've gone through the expansion extremely quickly, but if you do it slowly with double bracket expansion and whatnot, you should get the same thing. What does this give me? 8n plus 8 on the top, and if I have done it correctly, I should get 4n squared plus 8n plus 3 on the bottom. Cool. So we still haven't shown that the top will be even and the bottom will be odd. So the way we do this, or the way you're supposed to do this, is you need to factorize this out. So I do need a little bit more space. So, alright guys, so it looks like from the mark sheet, if you leave your answer like this, then you would get the E mark. But I want to take a little bit of a time to explain why this is even over odd. So remember that n can be some integer value. Now, if you don't know what an integer is, it's essentially a whole number. So 1, 2, 3, 4, 5, blah, blah, blah. It could even be a negative. So it could be -6, -5, and so on. So it goes all the way to infinity. So the proof is, or the claim anyway, is that any integer times an even number gives an even number. So let's just try some examples. Even though that's not a proof, we can just use it to get some intuition. So let's choose a integer. Let's choose 3 multiplied by 8 is equal to 24. Now 24 is an even number, so that's cool. What about, let's choose another random number. Let's try -6. -6 times 8 gives -48, which is an even number. So that any even number multiplied by an integer gives an even number. So 8n, it's always going to be even. Now, we've got a +8 here. So an even plus another even number always gives an even number. Let's try it out. We've got an even number 24 added with 8. That gives 32, and 32 is an even number. So hence, our numerator is always going to be even. Now, let's try the denominator. Let's see the denominator. So, remember that n can be any integer. So let's try 3. So 4 multiplied by 3 squared. Now this is going to give me 9 times 4. And remember that in an odd times an even, it's still going to give me an even number. So an even number times anything gives an even number. So this is equal to 36. Now we've got 8 in here. And we just proved prior that 8n gives an even number. So 8 times 3 was 24. 24 is even, so we got 36 plus 24. We know that this part here is even, right? But now we've got a +3 here. Is +3 even? The answer is no. +3 is not even. So if we add even and odd together, an even plus an odd number always yields an odd number. So what's 36 plus 24, for example? That should give me 0, 1, 60. But 60 plus 3 is 63, which is odd. Hence the denominator always gives an odd number. Alright, so you can see I had some major troubles trying to simplify down C in terms of A. I just did none of it right. That's why I got a not achieved for that part. Awesome, guys. Thanks for checking out this walkthrough on the 2017 MCAT. And stick around for the next video. Cheers.
Sky, yeah, we just fly, yeah.